Okay, so usually when the two functions are different from each other, so you see we have cosine and sine inverse, they're not both cosines, they're not both sines. Usually your best option is to draw a picture. Any type of right triangle will do, doesn't have to be anything special. So a right triangle, I would label, A, B, and C. Usually C is our right angle. Again, nothing particularly special. And what you want to do is you want to start by saying, let this inner function right here, the one that's representing an angle, right? So let sine inverse of 4/5 be equal to theta because that's an angle, right? So what we're going to do is we're going to place theta somewhere within this triangle. I'm going to put it here on B. Again, you can put it on A just as easily. This means that sine of theta is equal to just that 4/5, right? Well, if you remember from our first definition of our trig functions, sine uses opposite over hypotenuse, right? That's our SO of SOHCAHTOA. So because this is opposite over hypotenuse, this actually is telling us about the number values for each of those pieces. So the opposite side from theta's location over here is 4, and the hypotenuse side, again, from theta's location, drawing over it too many times, is 5. So the only other thing we may need to find, potentially, is this side right here. So now, what we want to do is we want to find cosine of theta, again, replacing that with the angle, right? So to find cosine of theta, we do need adjacent over the hypotenuse. So we do need to find that mystery side. So let's take a moment and do that. So somewhere off to the side, you've got 5 squared is 4 squared plus a squared, right? That's 25 is 16 plus a squared. Move the 16 over on both sides, right? Cancel it on this side. And you get 9 is a squared, which means a is equal to 3, right? So this side down here is a 3. Well, now that I have that side, we can find cosine without any trouble, right? Just 3/5, okay? So I would kind of wrap that up by restating the question. I think a good kind of final thing to do is to say cosine of that sine inverse of 4/5, right, is equal to 3/5. And you want to make sure this lines up with the given information. What I mean by that is ultimately, or the last thing we're computing is cosine of an angle, right? Cosine of an angle. So I should make sure that I get a side length as my answer. If the order of these two was reversed, then I would want to make, I'd want to make sure I got an angle back as an answer, okay?